Okay, for the second lesson, we're going to take a look at acceleration. So acceleration indicates how fast the velocity of an object is changing. Or we could say that it is the rate of change in velocity with respect to time. Acceleration is given by the derivative of the velocity of the function or the second derivative of the position of the function. So we could say that acceleration is equal to the limit as time approaches 0 of the change in velocity divided by the change in time, which is equal to dv over dt, or the second derivative of s over d of t squared. If the acceleration is positive, the velocity is increasing. If the acceleration is negative, the velocity is decreasing, which we sometimes refer to as deceleration. If the units for velocity in meters per second, then the units for acceleration are meters per second squared. So, putting this into practice, for example 1, it says the position of a particle in meters is given by s is equal to t cubed plus 5t squared plus 7t, where t is the time in seconds. Find the velocity and acceleration as a function of time. Well, what do we know? We know that the velocity as a function of time is equal to s prime of t, or the derivative of s, which is going to give me 3t squared plus 10t plus 7. I'm just taking the derivative of my original function. If I want to do acceleration, then that is going to be the derivative of the velocity, or the second derivative of the position, which means I'm just taking the derivative of this velocity here, which is just going to give me 6t plus 10. When it says find the acceleration at 3 seconds, then the acceleration at 3 seconds is going to equal 6 times 3 plus 10, which is going to give me 28 meters per second squared. For example 2, it says a ball is thrown upwards with an initial velocity of 24.5 meters per second, and its distance above the ground in meters after t seconds is going to be s is equal to 24.5 t minus 4.9 t squared. Find the acceleration of the ball. Well, just like in the previous example, I'm going to solve my velocity first, which is once again my s prime of t, which is going to be, when I take the derivative of this, 24.5 minus 9.8 t. When I find my acceleration, I'm taking the derivative of the velocity, or the derivative of this, which is going to give me negative 9.8 meters per second squared. Now, anybody who's taken physics should recognize this as just the acceleration due to gravity on Earth, just rounded to the nearest tenth instead of the nearest hundredth, like you usually use in physics. All right, let's take a look at one more example. So it says the displacement s of an object moving along a horizontal line is given by this function. S is equal to t cubed minus 6t squared plus 9t minus 20, where t is greater than or equal to 0, where time is measured in seconds and displacement is measured in meters. Find the initial position, initial velocity, and initial acceleration of the particle, and describe what each of these means. Well, what does initial mean? Initial is a fancy way of saying when the time is equal to 0. So what am I going to say about this one? Well, first, we're going to start with the position. So if s as a function of t is equal to t cubed minus 6t squared plus 9t minus 20, then I'm going to take when that s is of 0 for t. So I have 0 cubed minus 6 times 0 squared plus 9 times 0 minus 20, which is just going to equal negative 20. I'm going to take the derivative of this to get my velocity, v of t. When I take the derivative of my original function, is going to give me 3t squared minus 12t plus 9. And when I take the velocity of when t is equal to 0, that's going to give me 3 times 0 squared minus 12 times 0 plus 9, which is just going to be positive 9. And when I go to acceleration, I'm going to take the derivative of that velocity, and I'm going to get 6t minus 12. So the acceleration at 0 is going to equal 6 times 0 minus 12, which is going to give me negative 12. Now, I need to make sure that I put the correct units of all these. So when I'm doing the displacement based on the information that it gave me, where the displacement is measured in meters, I'm going to say that the displacement is actually negative 20 meters. I'm going to say the velocity, because the time is in seconds, is going to be in meters per second. And I'm going to take the acceleration and say that's going to be in meters per second squared. Now, what does this actually mean? Well, because it said that it's moving on a horizontal line, and I know that it's going to be going from left to right, I have an object that is starting to the left of the origin, because it's negative 20 meters. It has a velocity that is positive, so it is moving right. And I have an acceleration that is negative, which means that it is slowing down. So, what am I going to say? I'm going to say that the object is initially 20 meters left of the origin. I'm going to say that the object is initially moving right at a speed of 9 meters per second. And I'm going to say that the object is slowing down by 12 meters per second squared. All right, go ahead and try some practice from 3.1 and 3.2.